Hello and welcome back to the channel. Today I have something quite interesting for you, and that is a V1V vacuum relay. It is made in the Soviet Union and I think it is quite interesting, and that is why I'm making a video about it today. So, as I said, this is a vacuum relay. It has a coil voltage of about 18 volts DC. In the datasheet they say that a nominal voltage of 72 volts is applied to the coil, but it will switch at a voltage greater than 18 volts. About the switching characteristics of this relay, we have a switching voltage of 3 kilovolts and a switching current which has to be smaller than 10 amps. They say it can last about 100,000 switching cycles, and the switching time is smaller than 20 milliseconds. And the contact resistance is about 20 milliohms. We will test the switching time and the contact resistance, but first let's give you a closer look at this relay. So here is the part number, which is in Russian, I think. V1V, 1V2. It has this glass body and the rest is made out of copper. This diode here I added for testing later. So the voltage when the coil is switched off isn't too great and does not damage my equipment. Inside the casing we can see the part that's switching. It is on some sort of a contraption. This whole base here switches up and down when you turn the control voltage on. I will demonstrate that here in a second. And up here you have two screw terminals in which you can connect your cables or your load that's being switched. It is made quite in a, I think it's a high quality thing. The glass feels really thick and it also has a certain weight to it, well, because it's made out of copper for the most part. On the back, I think maybe this is some quality control. Here we have the rating, 10 amps, 3 kilovolts, and I think this is the company logo that made these, but I'm not quite sure. On the bottom we have the contacts for the coil, a little screw and some holes where you can mount this thing on a base. So I wanted to tell you something about an application for this thing. Because it has a vacuum inside, you can reach that high of a switching voltage, like in this case 10 kilovolt. Because of the vacuum inside, it isn't as common or sparks don't form so easily inside there because of the vacuum. So this makes it ideal for a number of high voltage applications. In the datasheet they recommend using it for some kind of switching for RF, about 30 megahertz or so. And this particular vacuum relay is also used by the hams for switching their RF amplifiers or stuff like that. And yeah, there's a number of applications for this thing. I just saw it at the market, like on display, and I just bought it because I thought it is interesting, and I also have not seen quite something like that. I have another normal relay like here for comparison. That one is not a vacuum relay, just an ordinary relay made by Omron, and yeah, that's quite two little different things with its own respective applications. So I switched the lens to a macro lens so we can see how the contacts are switching, and I applied a voltage of about 15 volts. Not quite the minimum voltage, but it nonetheless switches. So let me turn on the voltage. And that is how it switches. So you can see the two contacts here on this side and the other side, and this thing here connects both sides with each other, and on the right and the left side here and here is where the screw terminals are. Let me go out a little bit and show it from the top so you can see a little bit more. Yeah, I just connected the coil to my power supply to power it. So here we see the base and the contacts in the top, and now I will activate the power supply so you can see how the base moves. And from the side you see it's on some sort of spring down there, which holds the base down here and switches the contact. So let me show you how that works from this angle. Alright, that's how this thing switches. So let's continue and measure this thing to see if the datasheet tells us the truth. So let's do it. Alright, just that you can see my settings here on the power supply. I've set the power supply to 27 volt as the nominal specified voltage in the datasheet, and at 27 volts it needs about 100 milliamps of current, and that equals to a coil resistance of about 270 ohms, and that's also like the datasheet specified. Alright, I have now connected the contacts to the Keithley 2001 multimeter and set it to 4 ohms or 4-wire resistance measurement. Right now the contacts are not closed, so that's good. We don't measure anything. So let me close the contacts. It's now measuring. Let it settle a little bit. So I think that's just some noise down there. But we have about 14 milliohms, and that is also better than what we expect from the datasheet. They declared a contact resistance of about 20 milliohms. We have 14 milliohms, so that's quite good. Alright, we're on the scope here. I'm not quite sure if you can see the cursor. Ah, no. Okay. I have here the 2 channels. On channel 2 is the input to the coil, so that is the switching voltage, and on channel 2 we have the contacts, and they're both connected to the same voltage. So we can, I started a measurement, so we can see down here. It says the time is about 10.5 milliseconds, so that's well within the specs of the datasheet. But here we can see some bounce on the contacts. So let's analyze that a bit. That's just the contacts. We can see it's now about 937 microseconds per division. So that's about 1 millisecond, let's say. So about 4 milliseconds before the bounce stops completely, and there's quite some bounce. So let's compare that to an ordinary relay. Alright, there you have it. I hope you liked this short little video about this quite interesting vacuum relay. Maybe I will find some application for it, where I can show it in action, but that is the video for now. I hope you liked it, and if you want to see some more Soviet stuff, I have quite some interesting little things here, like this vacuum capacitor or the classic Nixie tube right here. So if you want to see a video about those, just let me know down in the comments, and I hope you have a great day. Until then, good luck and goodbye for now.